Okay, so we're videotaping. Alright, today we're going to learn about how to write and name acids. So that is our heading for today. And we are going to use our models that we drew yesterday for these particles. Okay, so acids and bases alike, but acids are tricky. There are two types. So there are two types of acids when it comes to nomenclature. There are binary acids. Binary acids are special because they have a hydrogen in the front. They're a hydrogen plus an element. So an example would be HBr, hydrogen and bromine. Now normally you would look at this and say, hey, that's an ionic compound. You're right, the hydrogen has a 1+, this has a 1+, and the bromine has a 1-, and because of their charges, they're electrically attracted to each other. You're right about that. However, it gets more exciting than that. It's much more exciting than that. This H does some really fantastic things. This H separates from this bromine when you put it in water. So we would write it like this. And this is what makes this an acid. Acids have these H+, these hydrogen ions are what acids have. The stronger the acid, the more H+ there are. The weaker the acid, the less H+. Now it gets a little bit confusing because you have to put this in water. You have to put this in water in order for the H+ to come off. And it gets tricky, and we'll have a whole chapter on this. It's called acids and bases. We'll have a whole chapter on when does this H+ come off, how often does it come off. We'll do all the math behind that. So don't worry about, hey, is this one where the H+ is going to come off, or is this one where the H+ is not going to come off? Don't worry about that right now. What we're worried about is when you look at this, what do you notice right off the bat? It starts with an H. If it starts with an H, a big red flag's going to go up. And that is going to tell you this is an acid. So that's the message here. So let's write that down. If it starts with an H, it's an acid. Okay, now if it's an acid, we have to name it in a special way. Now notice this one right here doesn't have any oxygen. So if it's an acid with no oxygen, then here is the rule that I'm going to use to follow to name it. So what I'm going to do is I'm going to add a prefix. Add the prefix hydro. Then you're going to have the element name. Then you're going to add the suffix ic to the end and the word acid. So let's highlight that. You're going to add the word hydro, you're going to write the element name, you're going to write an ic, and you're going to write acid. So what would the name of this be? Let's use our steps. There's a H there, so this is a hydrogen. So what are we going to write first? Hydro. And then what is the name of this element right here? Bromine. We're not going to write the mean. What are we going to write instead? Ic, acid. And that is the name of a binary acid. Hydrobromic acid. Later in our teachings and learnings, we will talk about how strong these acids are, which is how often the H comes off the Br. Okay? And then we'll classify it as a weak acid or a strong acid. Okay? Okay, now that's the first type of acid. The second type of acid is a little bit more interesting. The second type of acid is called an oxyacid. An oxyacid has oxygen in it. So it starts with a hydrogen and it has oxygen in the anion. Here is an example, HBrO3. Do you see how it starts with a hydrogen? It starts with a hydrogen, and if we're going to draw the model of that, what would we have? We'd break it up into its cation, and then we'd have the anion. And remember how we talked about how the oxygen doesn't like each other, so they're going to be as far apart as possible. Then what charge does this have? What does BrO3 have on your ion sheet? 1 minus. So you have this right here is being attracted to this right here, right? Electrically attracted. Okay? Now I have to name this. Do you see the oxygens in the anion? Do you see how our model is helping us name this because we can picture it in our head? Okay. So what are our rules with this? This is a little bit tricky. I'm going to write the name of this right here. This is, what was the name of this ion? Can you tell me on your ion sheet? Bromate. I'm going to write that down. That will help us learn our rule. So let's put this on the shelf. I'm going to tell you the rule now. Here's the rule that we are following. If you have an 8, you're going to change the 8 to an ic and put the word acid. If you have an ite, you're going to change the ite to us and add the word acid. So that is our And this really isn't a step-by-step. This is actually a rule that you just have to follow. So let's try it. Let's name this acid now. Using our rule here. I have a what? What is this? 8. So I'm going to change the 8 to a what?
8.
And then write the word?
Acid.
So this is? No, not hydro. Bromic acid. Let's try another one. Let's try another one. How about HBrO2? What would that one be? So the name of this one is there. What would the name of this one be? What's the name? You have to look up the name of the anion. What is it? Bromite. Change the I to what? So this is bromous acid. It's that simple. And that's how you name an acid. So if I say the word hydrochloric acid, you should be able to write the formula for that. There's an H and what? Hydrochloric. An H and a chlorine. Then you got to look at the charges and do the math. Okay?